So the next topic is define a strain gauge and explain the electrical strain gauge. As we all know the definition of the strain gauge, a strain gauge is a device used to measure the amount of strain in an object. So it is a measure, it measures, okay, when the object deforms or a strain, the strain gauge deforms as well, causing its properties to change. The change can be measured to determine how much the object has deformed. So in this strain gauges, there are different types of strain gauge: mechanical strain gauge, electrical strain gauge, and optical strain gauge. And the today's session we will study about the electrical strain gauge. Electrical strain gauge measures a strain by detecting a changes in electrical properties such as capacitance, inductance, piezoelectricity, or resistance. Among these, resistive strain gauges are most commonly used. The following is followed by inductance gauges. So look at the diagram here. By looking at the diagram, you can name it as laminated iron core, adjustable strength tapped inductance, laminated iron armature, laminated iron core, microammeter, condenser, and laminated iron core, and a supply. Okay, you have a supply here, so that is connected to a laminated iron core. You also have an adjustable center tapped inductance here, which can be adjusted. Let us look into the types of electrical strain gauges first. So there are two different types of electrical strain gauges. Those are resistive strain gauge, inductance strain gauge. So in the resistive strain gauge, the resistance of a thin wire or metallic foil changes when it is deformed. The advantages are high accuracy, resistivity, widely used in various applications. Inductance strain gauge. These changes in air gap between a laminated iron armature and two iron core causes the changes in inductance. This results in current flow proportionally to the relative motion between gauge attached points. So these are the types of strain gauges. You need to know it is a resistive strain gauge as well as inductance strain gauge. So first thing is, when they ask the question, you need to explain the strain gauge and then you need to get into the electrical strain gauge, and you are supposed to write the different types of strain gauges and then you need to explain the design. So as we discussed in the we have explained. I have discussed the two types of strain gauges. You also have an piezoelectric. There are three types of electrical strain gauges. You have three types of electrical strain gauges. The last one is a piezoelectric strain gauge. So let us look into the what do you mean by strain. First of all, piezoelectric strain gauge. So before that, let me tell you three types of strain gauges, that is electrical strain gauge, inductance strain gauge, and piezoelectric strain gauge. So in the electrical strain gauge, the components used are two laminated iron core on a frame piece mounted to the test specimen and a laminated iron armature situated between the cores. How does it work? Operation. When the specimen deforms, the air gap between the armature and one core increasing while it decreases for the other core, changing the inductance and resulting in a measurable current change. What are these advantages? Easy readout, high output. Disadvantages: high mass, large size, and longer gauge length, making them suitable for permanent installation rather than dynamic strain measurement. The next one is a piezoelectric strain gauge. So how does it work? These crystals like quartz generates electrical charges when subjected to a mechanical stress. So here this quartz plays a major role here in the piezoelectric strain gauge. So what are the advantages of that? It is a self-generating, requiring no external power supply, and produces significant output per unit strain. Disadvantage: cannot measure a static strain. The calibration is challenged due to mounting effect and can reinforce the measurement point, altering the strain field. Inductance strain gauge is an example. So here how does it work is inductance strain gauge. Here the two iron core, the components which is required for the inductance strain gauges, it requires two iron core with a coil, frame piece and an iron armature. Mounting the frame piece is attached to the test specimen with armature fixed at the other end. The coming into a measurement, as the specimen length changes, the air gap between the armature and core varies, altering the inductance of the coil. The change in inductance produces a current proportionally to the motion, indicating the relative moment between the gauge points. So coming into an advantage, easy to read, produce high output, suitable for measuring the relative motion in permanent installation. Coming into a disadvantage, it has a high mass and large size and longer gauge length, not ideal for dynamic resistance. By this, we will say that electrical strain gauges are a vital tool for measuring a strain through changes in electrical properties, and resistive strain gauge are the most popular due to their accuracy and sensitivity. Inductance strain gauge, while less common for dynamic measurement, are useful in permanent installation. Piezoelectric strain gauge offers self-generating capability but are limited by their inability to measure the static strain and calibration difficulty. By this, we will end the electrical strain gauge. These are a few summary points which I had discussed at the end. By this, you can remember the different types of electric strain gauge. The next one is define a strain gauge and explain the optical strain gauge. So as we all know, strain gauge is a device used to measure the strain in an object. When the object deforms, the strain gauge also deforms and causes a measurable change in its property. This change is used to calculate the amount of strain. Optical strain gauges working principle. Optical strain gauge uses a light to measure a small displacement and a strain. And these gauges employ optical method to detect the changes in distance or angle caused by deformation, providing high precision measurement. There are different types of optical strain gauges. The types are Tuckerman gauge. So what do you mean by Tuckerman gauge? Here the components are extensometer made up of steel or aluminum alloy which with an adjustable gauge length from 6 to 380 millimeter. Autocollimator, an optical device that sends a parallel ray of light and receives the reflected ray. So let me tell you one thing, optical means a light. Okay, these gauges are used light to measure the small displacement and the strain. Okay, you have a different types of gauges. First one what I am explaining you is a Tuckerman. So how it actually works, how it is being made up of, that is nothing but extensometer and autocollimator. Coming into an operation, The extensometer has a fixed knife edge and a movable knife edge which acts as a mirror. When the object deforms, the distance between the knife edge changes and causing the law to rotate. The autocollimator projects a light beam onto a lozenge and the reflected beam deflects is measured. The deflection is calibrated to measure a strain with the system capable of measuring up to 2000 millimeter of strain. So look at the diagram now. You can see in the exam they do ask a Tuckerman optical strain gauge. You can see you have two different diagram. The first one is, you can see you have a reflector, adjustable eyepiece, lamp, image and scale bearing reticule, autocollimator, objective lens, prism, extensometer, knife edge, test piece, lozenge, extensometer, prism, adjustable screen. This is a one diagram. Coming into a second diagram, you can see you need to write the second diagram. Here for the Tuckerman, you have a knife edge, nominal gauge length, prism, adjuster, front face, light path, back, prism, roof surface. So let us look into it. So coming into an advantages of Tuckerman optical strain gauge, it has a high precision and no need for a autocollimator to be fixed and relative to the extensometer. Limitation: suitable for static measurement and requires large gauge length, making it unsuitable for area with large strain gradients. The next one is interferotype. In the interferotype, the principle is it uses a principle of light interference where two light rays with a path difference of half a wavelength produces interference fringes. Okay, these fringes can be used to measure changes in thickness or deformation. What are the application? These applications they typically used in laboratory to measure the properties like Poisson's ratio and Young's modulus. So here the advantages are they are extremely high sensitivity. So coming into a limitation, not commonly used outside of specialized application due to its complexity and sensitivity. Here we have a precision. The optical strain gauge offers a very high precision in measuring small displacement. Static measurement, they are the best suited for static measurement due to the inherent limitation of mechanical system in dynamic environment. Calibration, optical strain gauges require careful calibration to ensure accurate measurement. Surface requirement, they need sufficient surface and area and clearance on the test specimen for proper operation. The optical strain gauges provide a high precise method for measuring strain using a light, while they offer significant advantages in terms of accuracy and precision. Their application is generally limited to static measurement and laboratory setting due to their complexity and the need for large gauge length. The Tuckerman gauge and interferometer type are the two common examples, each with unique benefits and limitation. So these are the limitation and advantages of the Tuckerman gauges. So by this I will end the video. So you have two different types of gauges which we have. You have three different types actually. In this video we have discussed the electrical and optical strain gauges. We will look into the few more example in the next class. Thank you.